Okay, so last time we considered the applications of partial derivatives, and we said really the applications in Math 201 can be thought of as really generalizations of the applications in Math 101. And we started with the main application of Math 101, which is finding the equation of a tangent line to a curve. And this is really the equation, the familiar equation here. And in Math 201, you have a generalization. Now we go to a surface and a tangent plane to a surface. So the main application in Math 201 is to find the equation of the tangent plane to a surface. Okay, so this is a surface and this is tangent plane at a point x0, y0. The equation is given as follows. Okay, which is really, you can think of it as really, if you compare the equation of the tangent line and the new equation for the tangent plane, really it is similar, okay, in form. So the value of the function at the point, then the derivative times the change, and now you have two derivatives, one with respect to x and one with respect to y, times the corresponding changes, okay. So this is for the equation of the tangent plane, okay. Then the next application was what we know, what is called in Math 101 linearization. The linearization of a function at x0 is just the equation of the tangent line. It is exactly the equation of the tangent line, but instead of writing y, we write always L of x. So you think of it as a function, L of x equal this, which is the equation of the tangent line. Okay, for the tangent line, it is y equals L of x. A new name, but it is called linearization. And the main application, the application of the linearization, again, it is just you can approximate the function, the value of the function, by the value in the tangent L near x0. When you are near x0, then you can approximate the function by the tangent line, by the linearization, which is the equation of the tangent line. So you can approximate the value of the function by the value on the tangent line, which is the linearization. Okay. The same thing for Math 201. You have linearization, still the equation of the tangent line, of the tangent plane, exactly the same form, but you write L of xy. And the application, when xy is near x0, y0, the value of the function is approximately equal the value on the tangent plane, L of xy, linearization, okay, the equation of the tangent plane, okay. So these are the two applications we considered. Still, we have one more application, But again, I will do it. I will start with Math 101. I will do the explanation in Math 101. Then the generalization will be direct to functions of two variables. Let me just recall why I started with Math 101. In fact, recalling Math 101 because of two reasons. The first reason, really, the ideas of Math 201 are really similar to those of Math 101. So if you know them in Math 101, they are exactly the same in Math 201. You can just do the generalization, okay? So it is better to understand them here and then just go there directly. The second reason, and maybe it is a main reason, it is regarding the graph, okay? When you graph a function in Math 101 and a tangent line, and when you explain the approximation, it is obvious, it is easy to see using the graphs of Math 101, using the situation for functions of one variable. When you go to Math 201, you have a surface and a tangent plane. My graphs will not be accurate, okay? Even if you check the textbook, I advise you to see the textbook to see the good graphs. But even there, you see sometimes some little vagueness or inequality, okay? But you should always check the graphs in the textbook. You might see them better. So really here, it is easier to explain with functions of one variable because you can see the picture clear, okay? Eventually, the situation is the same for Math 201. So we just go to the generalization without graphing. Check the graphs in the textbook for functions of two variables. Okay, this is the reason. So now we go to the third application, which is differential. Again, I will just go to math 101. So differential, you have y equals f of x, and you have the differential of y, okay, denoted by dy. So it is differential of y, okay, is defined as follows: dy equals f prime of x dx. What is dx? Dx, the differential of x, the differential of x. So here we have two variables, x and y, the independent variable x and the dependent variable y. The variable of the domain x, the variable of the range y, okay. For this variable, there are differentials, two differentials. Differential in y, dy, differential of x, dx, okay. These are, how are they related or defined? They are given in this manner. dy equals the derivative times dx, okay. dy and dx, look at them as small changes, really, small changes. So this is a quantity, a small change in y. Dx is a small, again, a quantity. You can think of it as a small change in x, okay. So this is the definition. The next step, we give the geometric meaning of the differential. What is the geometric meaning of the differential? And what is the application of the differential, okay. So this is what I will do next, okay. But from the definition here, okay, we can go to the definition. We generalize this definition to the definition for function of the differentials for functions of two variables. If you have a function of x and y, we say the differential of z, the differential of the range value. Notation dz, okay, is defined as, okay, dz equals. It is a generalization of math 101. We have y equals f of x. The differential is h, dy, the derivative dx. Okay, dx. Here it will be h, dz will be, and I have to have a derivative here. Can you guess what should I write here for derivative? And f prime here, and what should I write here for functions of two variables? Make a guess.
Z sub x.
I have to use f sub x and f sub y, both derivatives, first derivatives, okay. So I have f sub x here, f sub x at xy, plus f sub y at xy, okay, times dx, differential of the domain. Now, what should I write here? Then I have to in the domain I have x and y. So I have a differential in x and a differential in y. The differential in x will go with the f sub x, so this is dx. The differential in y will go with the f sub y, okay. So you have three variables, z, x, y, two in the domain and one in the range. Then you have three differentials, dz for the range, dx and dy for the domain, okay. So dx and dy, the differentials in x and in y respectively. Okay. So this is the generalization of the definition of that differential, okay. So you take it now as a definition. Now we continue again. So the main point here, what is the geometric meaning of this definition? So what is this definition? What does it give us? Okay, so what is the geometric meaning of the differential dy, and what is its application? So this is what we will do next. Okay. So we start with the geometric meaning, and for the geometric meaning, just pay attention here. You have again, you have just a curve here, the xy plane, and this is y, and this is the graph here. Okay, and this is x0 here, this is x0 here, and this is f of x0, and you have also the tangent. So this is y equals L of x. You think of the line as a curve, and this is h y equals of x. You have a curve and a tangent line, the usual as we did h above. Okay. Now we have the following. So I will move from x0 to x1. So this is x1 here. x1, okay. So I will move along as x, let me say, as x changes from x0 to x1. Okay. The change in x is, just recall the notation, change in x, the notation we use delta x, okay. So change in x, delta for the change. This is the notation for change. Change in x, delta x, okay. This is the notation for it. What is the change in x? It is x final minus x initial. So هتكون x1 minus x0, okay. This is the change in x. So in the graph هنا, if I go from x0 to x1, now this is f of x0 and this is f of x1. So this is f of x1 here. This is f of x1. So I go from here to here, and this is h. Okay. So from x0 to x1, the change in x is here delta x. This is delta x. Delta x. Okay. So this is h in the graph. Okay. As I go from x0 to x1, x's changes. For this change, there is a change in y. The corresponding change in y, the corresponding change in y, okay. One here, along the curve, y equals f of x is. So move now along the curve. What is the corresponding change in y? Again, change in y, notation هيكون ايش؟ delta y. Change delta. Change معناتها delta. The notation is delta. Change in y. Along the curve. So when I go from along the curve from x0 to x1, I am moving along the curve y equals. So I go from f of x0 to f of x1. So what is the change in y? The difference f of x1 minus f of x0. فthis is ايش ده يعني f final minus f initial, f of x1 minus f of x0, f final minus f initial. From in the graph it is this one, from here to here, from here to here, this is delta y. Okay, this is the change in the change in y corresponding to the change in x. Okay, when you go from x0 to x1. Okay, so this is the change in y. Okay, here I will write it in this form. طبعا from here I can just get what is x1 here هتكون x0 plus delta x. x0 plus delta x. So here I can replace x1 by the following of x1 x0 plus delta x minus f of x0. Okay. Change in y again, f final minus f initial. Okay, so this is what we have initially here, and this is just a reminder of what we did in Math 101. I hope it is clear up to now. If it is clear, please write one in the chat if it is clear up to now. Okay, write one in the chat. Okay, just a reminder of what we have, basic thing, a very basic thing from Math 101. Okay, now pay attention. طبعا this is Math 101. طبعا we have to go to something new. Okay, now again, so I have the change along the curve. When I go from x0 to x1, this is the change along the change in y along the curve. I will do the same thing. I will move from x0 to x1, and I will consider y, but along the tangent line. Along the tangent line. Okay. I will move now along the tangent line. So the tangent line, you start at x0, this is that L of x0, so this is the same thing, L of x0. At x1, on the line, the tangent line, this is L of x1, this is L of x1. When you move along the tangent now, okay, so here the corresponding change in y, along the curve, now along the tangent, now along the tangent line اللي هو ايش y equals L of x. It is what? It is h delta y also here, which is also delta L, just to change notation. What is the change in y, in L or in y along that time? Again, L final minus L initial, L of x1 minus L of x0. So the change always L of final minus L of initial. But now we are on a different curve. Now Lx1 also as above, it is x1 عبارة عن x0 plus delta x minus L of x0. Okay. I will compute this. What is L of x0 plus delta x? Can I compute this? Yes. Why? Because I have a formula for L. It is the linearization, okay? And this is what we did last time, okay? This is what we have last time. So what is the formula for L? This is the formula for L. So this is the formula, okay? Now find L of x0 plus delta x equal. So just replace x with x0 plus delta x. هتكون ايش؟ of x0 plus f prime at x0 plus delta x minus x0. Okay. So this becomes f of x0 plus f prime at x0 delta x. And x0 with x0 will cancel. Okay. So this is L of x0 plus delta x. So let me write it down here. I have a formula for L, so I can compute L of x. So this becomes f of x0 plus f prime at x0 delta x minus, what is L of x0? Again, substitute x0 there, you will get f of x0, f of x0. Now f of x0 will cancel with f of x0, get f prime of x0 times delta x. Okay. So this is the change in y along the tangent, f prime x0 times delta x. Now when we deal with differential, dx, this is quantity, again, dx always we take it to be dx, we take it to be delta x, always, okay. And this is for the domain variables. In the domain variable dx, we take it to be the change in x, delta x. So we use this, so now I can have the following. Then I will replace delta x by dx. So this is f prime at x0. Delta x becomes dx, okay. Okay, in this case, what is f prime x0 dx? What is this quantity, okay? Well, if I go back above in the definition of the differential, this is dy, the differential. لاحظ dy equals f prime dx, okay. It is the differential in y, okay. فهنا this becomes this, I write it f prime x dx هيكون ايش dy at x equals x0. Okay. dy equals x at evaluated at x equals x0. Okay. Okay, so this means what? Okay, what is the conclusion here? Okay, what is the geometric meaning of dy, the differential? It is the change in y along the tangent line, okay. The change in y, along the tangent line, This is the geometric meaning of the differential dy, okay. To summarize, again, you have a curve and a tangent line at a point x0. A curve and a tangent line, okay. فهنا just هنا هيكون هذا dy معناته. From here to here, this is ايش dy, okay. To summarize, you have a curve and a tangent line. When you move from x0 to x1, there is a change in x. Corresponding to this change in x, there are two changes in y. One change in y along the tangent, along the curve, and one change in y along the tangent line. The change in y along the curve is delta y, f final minus f initial. This is the change along the curve. The change in y along the tangent line, is the differential dy, okay. dy, okay. This is what it is, okay. Delta y and dy, there are changes in y, but one along the curve and one along the tangent, okay. This is the geometric meaning of the differential. Okay. Now, what is the application of the differential? Okay. Again, you can find it from, you can see it from the graph. Notice this is at x1. At x1, you are, this is dy, and this is delta y. Okay. If you choose another value closer, this is x2, for example. When you go from x0 to x2, this is the dy, and this is delta y. Okay. Choose x3. This is x3. This is dy, and this is delta y. This is dy, and this is delta y. Okay. So when you go near x0, what is the relation between delta y and dy? What happened to them when you are near x0? Okay. They get ايش closer and closer. صح ولا لا? The two values get closer and closer because this difference gets smaller and smaller until you reach x0. So really near x0, delta y is approximately equal as dy. Okay. They are very close to each other. Okay. So this is, we say, for the application when x is near x0, when x is near x0, we have delta y is approximately equals dy. You can approximate the change in y along the curve by the change in y along the tangent. Okay. So this is what it says. Okay. Okay. Is it clear or not? Okay. If it is clear, write 2. If it is clear, write 2 in the chat. Okay. Write 2 in the chat. Okay. It is a matter of change. A change along the curve and a change along the tangent. This is what it is. Okay. And we can approximate the change on the curve by the change on the tangent. Okay. The idea is simple, really not difficult, but maybe when you have too many notations, it becomes a little bit confusing. Now this is H for Math 101. You do exactly you do the same thing for Math 201. You just do the same thing for Math 201. Okay. فهنا you just copy and paste with and make the necessary changes. So when xy changes from x0 y0 to هناك كتبناها x1 y1 صح ولا لا؟ اوكي which is ايش بعدين x0 plus delta x y0 plus delta y. Okay, which is x1 y1. Okay, when xy changes from, then the corresponding change in z. So in the plane you move it from a point to another point, then you have two changes in z, one along the surface z equals of xy. What is it? It is delta z. The changes is delta of a final minus of initial. This is the change on the surface, f final minus f initial. Well, the change and along the tangent plane, اللي هو ايش؟ عبارة عن ايش؟ z equals L of xy. Okay. Along the tangent plane. هيكون delta z or just delta L, L of final x0 plus delta x, y0 plus delta y, minus L of initial x0, y0. Okay. I have a formula for L, just substitute and simplify. You get h the following: f sub x at x0. You substitute, you get the following: f sub x at x0, y0, delta x, plus f sub y at x0, delta y. Okay. Again, in the variable of the domains, dx and dy, the variables of the domain, the differentials of the domain, dx and dy, dx will be always taken to be delta x, and dy will be always taken to be h delta y. Okay. For the variables in the domain, the differentials of the variables in the domain. So here, dx delta x, I can write it as f sub x at x0, y0, dx plus f sub y at x0, y0, d, dy, okay. But what is this? This is the differential, dz, d, dz. If you compare the definition, this is the definition. So whole thing here, it is dz. It is the differential at x0, y0, evaluated at x0, y0, okay. So what is dz? It is the change in z along the tangent plane, This is the geometric meaning. So delta z, the change in z along the surface. dz, the differential, the change in z along the tangent plane, okay. And the application when xy is near x0, y0, we have delta z is approximately equals dz, okay. So this is the generalization from math 101, okay. It is actually not difficult, okay. Now I will illustrate this with two examples. So just pay attention to the example. Okay, example here. Yani here, I will try to solve the example. Yani, in such a way that you should be able to solve it even if you did not fully understand what was explained so far. And if you did not fully understand it, again, still you can solve the problems, okay? So pay attention how to really feel comfortable. No, I can solve it even if the whole idea is not fully clear, okay? So now let f of xy, let z equals x squared plus 2y squared. Okay, if xy changes from 2, 3 to 3 to 2.1, 2.9, okay. Then find then estimate the resulting change in z. Pay attention, try to, yani, I will solve it in such a way that really you can do it even if you did not understand fully what I explained above, okay. Follow me carefully, okay. Now estimate the resulting change in z. First question, change in z. What is the notation for change in z? Okay.
Delta z.
Delta z. Delta z. Change معناتها delta. Okay. Now what is the question? Estimate the resulting change in estimate delta z. This is the question of again, estimate the resulting change in z معناتها estimate delta z. Question. Now, do you have a formula for estimating delta z or not? Okay. Do you have a formula for estimating delta z? Okay.
We have 4D.
dy dz
معناتها you have which is this formula, صح ولا لا? Delta z is approximately equal dz. This is the formula. You just go and apply it, okay. If we have a formula, things becomes very simple. So the answer حتكون ايش؟ delta z is approximately equal dz. Okay, now I go and calculate dz. This is what I need, okay. So this is now, what is dz, okay. Well, I have z equals, what is my f of xy here? This is x squared plus 2y squared. So z dz, f sub x, xy dx plus f sub y, xy dy. This is the definition of the differential. What is f sub x? It is h2x times dx. Plus what is f sub y? 4y times dy, okay. Now here, what is dx and what is, I need to substitute here, طبعا, okay. What is dx? Okay. What is dx now? Okay. By definition, it is h delta x in the domain, okay. What is delta x? X final minus x initial, okay. I go from 2.3 to 2.1, 2.9. X final 2.1 minus 2. So 2.1 minus 2, which is h 0.1. What is dy? It is delta y. Y final minus y initial حتكون 2.9 minus 3, which is minus 0.1. Okay. So I have now dx and I have dy. I need x and y. What are the values of x and y? Now for x and y, should I choose the xy for the initial point or the terminal point? Okay. For xy, okay. Initial or terminal, what do you think? Okay. Choose the initial. لاحظنا dz at x0 y0, the initial. Okay. You choose the initial. Okay. For xy, choose the initial. معناته x equals 2 and y equals 3, the initial point. Okay. x2, 3, this is at the initial. Now I have xy dx, substitute here, substitute, get h. هتكون 4 times 0.1 plus 12 times minus 0.1. So this is 0.4 minus 1.2, and this is minus 0.8. Okay. So delta z estimate, and then delta z is approximately equal dz. What is dz? Minus 0.8, minus 0.8. Okay. And this is how it is. Once you have a formula, just go and add the formula. Okay. It helps you really make things easy for you, even sometimes if you did not understand a certain concept fully. Okay. Okay. But this is one example. Okay. If it is a clear right number 2 or not, is it 2 or 3? I don't know. But this is write 3 in the note. If it is clear. Okay. Write 3 in the note. Okay. So just you have a formula, delta z, estimate delta z, just approximately equal dz. This is the formula. Go and compute and things will be very simple. Okay. Now we have another example, so pay attention. So the second example, really, if you understand the first example, the second example will be really similar. There is a key point in the second example. Once you understand it, then you are really in example 1. Okay. It is a word problem, so it is the radius of a cylindrical can. Is measured as 2 centimeter with an error in measurement of at most 0.1 centimeter, and its height is measured as 5 centimeter with an error in measurement of at most 0.2 centimeter. The question, estimate the maximum error in computing the volume of the cylinder. Okay, pay attention. That is really, it is not difficult. You will see now. Okay. When you read this question here, what is the key word in the statement of the question? What is the key word? Okay. What is the word that really is a key word? If you understand that word, then it's very simple.
Height and rate.
Again, what is the key word in this problem here? Okay.
The error.
Error. The word error. Okay. If you know what we mean by error here, you will see now really things are not difficult. Okay. So in word problems, when you see the word error, error, it means delta change يعني. It means ايش delta. Okay. So this is the keyword. Okay, now with this keyword, with word problems, عادة we read and write down the given information and state what is required. So you have a cylindrical can here, a cylindrical can. So this is a cylindrical can. Okay. Read, okay, the radius of a cylindrical can is measured as 2 centimeters. So I will take R for the radius. This is R. So R. What is it R? The radius is 2, so it is H2, 2 centimeters. Okay. With an error in measurement of at most 0.1. So error in measuring the radius. Error in measuring the radius. Okay. So what is the notation? The notation for error in measuring the radius? هتكون ايش؟
Delta R.
Delta R. Okay, this is what it is. Error in measuring the radius معناته delta R. Okay. So بقى it is of at most 0.1. So what does this mean at most 0.1? يعني if you say at most عادة تكتب less than or equal. صح ولا؟ At most less than or equal. Okay. But here it means the following really. Okay. It means more. Okay. يعني you are measuring the radius. You find it to be 2 with an error of at most 0.1. It means really you take it to be 2. You use a roller and you find it to be 2. plus or minus 0.1. Okay. plus or minus ممكن تقول 2.1 أو 1.9 at most. يعني هنا error, it can be maybe you made an error in increasing the value of the radius or in decreasing the value of the radius. Okay. really the delta R here should be maybe also a negative. So how to increase the negative values? Okay, we just put absolute value. Okay, absolute value. And you say delta R is less than or equals at most هتكون 0.1 either in the increasing or decreasing direction. Maybe it is 2.002 أو لا 1.098. Okay. To take all possible values and it is delta R هتكون ايش between 0.1 and minus 0.1. Okay. All of these are possible values for the error. يعني 2 plus minus 0.1 or less, 0.1 or less. This is what it means in measurement. A measurement of at most 0.1. This is what it means. Okay. You continue, and the height is measured to be 5 centimeter with an error in measurement of at most 0.2. معناتها again delta H less than or equals 0.2. of error could be positive or negative but ايش absolute value. So هتكون between 0.2 and minus 0.2. Okay. So this is the given information and how they are written. Okay. Now the question, estimate. I will leave the word maximum for a while. Just estimate. Estimate the error in computing the volume. Okay. So here I need the question, estimate what in notation? Estimate what? Okay. Error in computing the volume. So what is the notation here? Okay. Estimate what?
Delta V.
Delta V. Yes. Estimate error. معناتها delta V. Error in computing the معناتها estimate delta V. Delta V. Okay. So this is the question. Estimate delta V. Error and V. So you translate the word into notation. So this is the question here. Okay. Now, if I want to find a brief solution, well, how to estimate delta V? Do I have a formula for it or not? Okay. What is the formula that I should use in it? يلا خلاص.
Delta Z.
ايش؟ DZ. Okay. خلاص الآن. This is the main application. But الآن any delta of anything will become approximated by D of the same thing. From delta to D, we approximate delta by the differential D. Okay. هنا Z هناك V حتكون V. The answer, the brief answer is the following. Okay. Delta V is approximated by dV. Okay. This is the brief answer. Now we go and compute dV. Okay. هنا volume. What is the volume of a cylinder? هكون by r squared h. This is the volume of a cylinder. So it is now V is a function of two variables, r and h. Okay, r and h are the variables. What is dV? هتكون V sub r dr plus V sub h dh. Okay, dh. Okay. It is a function of two variables. The variables now r and h, not x and y. The r and h. So V sub r dr plus V sub h dh. Compute. Okay. So this is what is V sub r? هتكون 2 by r h times dr plus what is vh? هتكون by r squared dh. Okay. Now substitute. Okay. This is h. Okay. Now I need to know RH and dr dh. What is r in my case, in my problem? Okay. What is r in my problem here? Okay.
2.
Do I have r? 2. It is given 2. Okay. This is 2. What is h? 5. It is given. Now I need dr and dh. I need dr and what is dr? Okay. dr, it is the same as delta r. Okay. Okay. Now what is dr? Now what is the value of dr? Okay. Do I have one value for dr? No, I have it. dr from between minus 0.1 to 0.1. I have infinitely many values. I have more than one value. Which one should I choose from these values? Okay.
Maximum.
The questions ask about the word maximum error. I need the maximum error. Okay. Then I choose the maximum value or of delta R, the maximum error in R. Okay. Because the question asked about the maximum, I choose the maximum error in R or the maximum value of delta R. So it is the following. Okay. Delta R هتكون 0.1. I say maximum. The same thing for delta H. dH هتكون delta H. And the maximum هتكون 0.2. Again, maximum. I have everything now. Just go and substitute. When you substitute and simplify, you get the following equation: 2.8 by centimeter cube. Okay. Centimeter cube. So the approximation delta V is approximately equals 2.8 by centimeter cube. This is H, this is really H, the solution. Okay. So it is really similar to the previous example. Okay. Half delta V approximately equals D of something. Once you know what, you just go and compute the differential and substitute, and you are. So it is really similar to the main idea is the same as the previous example, but here it is a word problem. So you have to know the volume of a cylinder, all basic shapes. Later on. Okay, so this is H, this example. Okay, any question about this example?
Doctor, what are the basic shapes that we should be aware of? The volume.
You have to know cube, you have to know sphere, you have to know cylinder. Usually these are the ones. But always check the examples in the book and the problems in the book. Whatever they will be the basic. Okay. The usual things. Okay. Now this is the end. There is a little point, a definition بالحقيقة. So I will just mention the definition briefly, and I will leave the rest for you to read from the note. Okay. A definition, which is in Math 101, again, when you have y equals f of x, we say f is differentiable at x0. What is the meaning of differentiability in Math 101? Okay. When you say a function is differentiable, it means what? What is the definition? Okay. ايش معناتها again?
Continuous.
No, it doesn't mean continuous. Okay.
The limit
differentiable doesn't mean continuous. Okay.
Smooth.
The limit exists.
ايوه من هالقبيل هذا I will give it ايش in a simpler form. هناك you have the continuity هناك in Math 101 you have a theorem. It says if a function is continuous at x0, then it is continuous at x0. So it is a theorem okay, not a definition. Okay. The definition is very simple. Again, just if a simple way to remember it. F is differentiable at x0. F prime at x0 exists. Okay, like differentiable, able to differentiate. You can differentiate. You can find the derivative. معناته f prime exists. Okay. So this is a simple way to remember the definition. Okay. We say in Math 101, we say a function is differentiable at x0 if the derivative exists at x0. Period. Okay. So this is a Math 101 definition. Okay. In Math 201, the definition is a little bit طبعا not exactly the same. There is an extra condition هنا. So هنا f, we say هنا f is differentiable. F is differentiable at x0, y0. Okay. If two conditions are satisfied. Okay. The first condition, it is the generalization of Math 101. معناته f prime حيكون f sub x and f sub y. معناته f sub x at x0, y0 and f sub y at x0, y0 both exist. So derivative becomes f sub x and f sub y. Okay. If both exist at x0, y0, and you can find both of them. Okay. But in Math 201 for functions of two variables, there is a little complication. It is not enough for this to be the definition. The definition will add some extra condition. Okay. Which is we have to check that f sub x at xy and f sub y at xy are continuous at x0, y0. They have to be continuous also, not only. Okay. So this is a little difference, little difference from Math 101. Okay. So you need also to check the continuity. Okay. So this is the definition for differentiability in Math 201. Okay. You read the example in the note, and it is just application to this definition. Okay. Yes.
الآن هو يقول differentiable if the derivative exists أول شرط.
Yes.
طيب تقدر تعطي له مثال بسيط عن متى الديريفيتيف ما تكون exist؟
We can give you but إنه بما إنه I can make one for you. خد بس مثلا absolute value f of x y equals absolute value of x plus y for example. هتكون هذا مثال Okay. And this is an example. Absolute value of x versus absolute value of y. Take 0, 0 for example. Okay. It will not be okay. هنا طبعا هنا طبعا the course in this course طبعا هنا just apply the definition. هنا there is no concentration on such a thing here هنا take it as a definition. But really this definition is used a lot in advanced courses when you need to prove certain things. هنا usually we are not proving anything فهنا you need just to take it as a definition And an example in the note أو في الكتاب, it shows you how you can use it is to show that a function is differentiable at a certain point. You just check these conditions, compute and see whether they are continuous or not. And remember always functions are continuous in their domain if a function is given by a single formula. So it is not difficult to check these conditions. Okay. There is no concentration on this notion in the book, but it is a definition. You have to know it. Okay. So this is the end of this. This is the end of this. Now, if you didn't have any question, you can leave. If you have a question, you can ask now. Okay. Have a nice day.
Doctor.
نعم.
What about the grade for the test exam, last test exam?
I mentioned in the beginning, no, خلاص, still we did not. I asked the coordinator about the complaints, your complaint, students' complaint, and he said he will, once they are done from dealing with those problems, the technical problem, they will inform us what happened. I did not yet receive the full answer or the full explanation of the coordinate. So once I received him, I will inform you.
So they didn't finish it yet.
And up to last night at 10 p.m. I did not receive anything. Okay, so I cannot say anything.
يعني دكتور they didn't complete the issue. They didn't finish from the
maybe
issue.
بما انه I have not received anything, maybe not, or maybe they are almost done يعني. So I have to wait until they respond and then I will inform you.
تمام.
دكتور.
نعم.
معلش بس كم غياب مجاني مسموح في المات؟
يعني قول يعني مش كثير، 2 مثلا او something like this يعني لا يكثر، لا يكثر يعني، الواحد يكون معقول فقط لا غير. انا حكون معقول يعني. اوكي.
طيب هل حتنزل جدول بعدد الغيابات او شيء؟
ان شاء الله later on يعني later on. اوكي يعني ان شاء الله.
يعطيك العافية.
If you have nothing, please leave. If you have nothing, please leave. اوكي.
يعطيك العافية.
حياكم الله.
شكرا دكتور، يعطيك العافية.
العفو، حياكم.
يا دكتور.
نعم.
أنا كانت عندي مشكلة في البداية دكتور، ما قدرت أدخل، عندي النت مرة تعبان.
كم دخلت؟ متى دخلت؟
طولت والله يا دكتور، ممكن 25
يعني دخلت at 25 يعني كذا.
أتوقع كذا دكتور.
طب قل لي بس حتى اسمك حتى أقول أوكي بالنسبة لك. أوكي.
عامر الجهني.
أوكي ما في إن شاء الله، ما في مشكلة إن شاء الله. أوكي. ما في
مشكلة. يعطيك العافية.
الله يعافيك. حياك. باسل الشهري. هاشم القرني.
موجود دكتور.
إذا موجود ليش ما مشيت؟ ليش؟ أوكي.
والله تونا جاي من دورة المياه دكتور.
لأنه اللي عادة اللي موجود عنده اسمه ما يرد معناته غايب، معناته أكيد جاء ومشى فقط لا غير يعني. أوكي.
لا مش حتى مش اسمه مشارك، يوم أنت تقول اكتب 1 2 3.
أوكي خلاص ما في.
دكتور.